So, happy green bean casserole day. A reminder too that we're going to have a formative on this week Friday. You'll actually have a formative next week Friday. And again, your test will be on the 18th, which is the Thursday before winter break. Okay? All right. It would be beneficial for you to have out your identity sheet all day today, and really all or every class period going forward up until the after the rest of the semester, to be honest. Okay. Also, I told you yesterday that you'll be able to use your identity sheet on the formatives, and that was because we put in for a classroom set of laminated identity sheets, and we didn't expect them back until like next week. We got them back yesterday, so you don't get to use yours. You get to use ours, which is just a blank one, which is just fine for everybody involved. So, okay, and the only reason that is because those came in well 2 weeks ahead of what we had them planned for. So, okay, so here we go. We're going to start out with no matter how many mistakes you make or how slow your progress. Sorry, the font is or the pixelation is bad. Or how slow your progress, you are still way ahead of everyone who isn't trying. Okay? And it's truly all about mistakes. Okay? You will make them. Okay? And you'll find that not necessarily so much this week, but next week for sure, and this week is getting you ready for next week, you'll find that I use this example a lot. And it's a good example. Everybody know where the Mosinee Airport is? Okay. Everybody knows where it is, south of here, right on the freeway. Yeah. What's the fastest way to get there? Jump on the highway, right? Boom, you're there. Okay. 15, 20 minutes-ish, depending on traffic. You're there, right? Okay. Is that the only way that you can get to there? No. You could go through town, right? You go down Grand Avenue, and once you get to, what's all on that corner now? There's a Walgreens now on that corner, and there used to be a flower store. I don't think the flower store's there anymore. Is Kruger still there? I think, okay, well, you got Kruger's flower, then you turn left, and then you go down, whatever that is, you go past Domtar Paper, and then you go past Cedar Creek, and then you can get to the airport that way. Right? Okay. Are those the only two ways? No. Okay. You could be really, really crazy, right? And you could go out to Marathon and then cut down 107 and then come back in on 153. Okay. That's an applicable way, right? It may take a little bit longer. Okay. Right? You'll see where this is all coming from in a minute here. Okay. May take a little bit longer, but you still get to the same destination, right? Okay. Now, some people, and this is more for next week, some people will go north on 51 to Merrill. And then they'll get on 64, and they'll take 64 east to 45 in Antigo. And then they'll get on 45 south in Antigo, and they'll go to Wittenberg, and they'll get on 29 west, and they'll come back to just the other side of Wittenberg, okay? And they'll get on 49 south, and then they'll get on 153 to the west, and then they're at the airport. Still made it to the airport, just took a much longer, more involved method, right? More chances to make mistakes, right? Okay. Still get there. Okay. That's what we're talking about. You may have a way of doing these next two problems that I'm going to show you. That's the highway. Boom, you're there. Okay. But your neighbor may be going over to Marathon and then coming back around. Both of you still get there. Okay? Okay? Both of you may make a wrong turn somewhere, okay? But the object is to still get to the airport. Okay? Okay? So there's more than one way of doing all of these problems. Now, with all of these problems, though, remember, you still have to show your work. Okay? You have to, because that's what we're grading. We are not grading the airport, we're grading the route you take to the airport. And if your route is good, then you're good. Okay? All right. With that being said, here are your 2 warm-up problems for today. Tangent divided by secant, and tangent times cotangent. Tangent is sine over cosine. Secant is dividing fractions. My 3 words are keep, change, flip. So I'm going to keep sine over cosine. I'm going to change to multiplication. And I am going to flip 1 over cosine to cosine over 1. That then allows me to cancel out the cosines because I have 1 on top and I have 1 on the bottom. And that leaves me just with sine of theta as my answer for that one. Yes? Okay. Tangent is sine over cosine. Cotangent is cosine over sine. Sines cancel each other out. Cosines cancel each other out. Everything gets canceled out. So my answer is just 1. Okay. Could have also done here the highway method. Tangent of theta times 1 over tangent of theta, and cross those out and gotten 1 that way. Okay. Questions, comments, concerns about either one of those 2? Try that one. Agree with me on that? Factoring out a cosine squared delta. One plus tangent squared is number 11 on our identity sheet, and that's equal to secant squared. Secant squared is 1 over cosine squared. The cosines cancel each other out, leaving me just with 1. Questions, comments, concerns, clarifications? Try that one. I get sine of x. Questions, comments, concerns, clarifications? What do you mean? When I first factored a sine? Because there were 3 sines at the start, right? Okay? And if I take one away, then I'm left with 2 sines, correct? So that's sine squared. Okay? There was 1 sine and 2 cosines, right? Okay? So if I take the 1 sine away, then I'm still left with the 2 cosines, right? So there's no need for a 1 there. Yep. It's a little different than the ones we had yesterday.
How is there addition in the parentheses?
Because there's addition in the original problem.
That's between sine cubed and regular sine.
No, it's between sine cubed and sine cosine squared. This is all one term here. It's no different than that. If you want to factor that, what are you going to factor in blue here? You're going to factor out an x, right? So I'm left with x squared plus 17. The 17 is being represented by the cosine squared. Okay. Okay. Mistakes are painful, yes. Okay. But no pain, no gain. Okay. So to add some more pain and some more groaning into your lives, let's talk fractions. Okay. Way back in 5th, 6th, I don't even know when you guys learned it anymore, but when you started learning adding and subtracting fractions, your teacher told you that there's one thing that has to happen if we're adding and subtracting fractions. What is it? Gotta have a common denominator. 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 Okay? So when it's just numbers, what is my common denominator? 15. Okay? What do I do after I figure out what my common denominator is? On both of them, right? I got to adjust both of them. Okay? So 1/3 adjusted to 15ths is 5/15. 2/5 adjusted to 15ths is, you said 6? Actually, truthfully, we'll go back one step here. This would be 1, this would be 2, and this would be times 5, and this would be times 3, because that's what we're multiplying by. And so then that gets me 5/15 plus 6/15. Now what do I do? Add the top numbers. What do I do with the bottom numbers? Keep it the same, right? Okay. 5 plus 6 is 11 over 15. And then what do I do? Try to simplify it. Can I simplify it? Nope. Okay. So it's just 11/15. Fantastic. Okay. In algebra then, we took it up a notch. Okay. And we said it's the same concept. Okay. You first have to find your common denominator. And in algebra, your common denominator, more than not, was just denominator times denominator. So this would be x times the quantity x plus 1. X times the quantity x plus 1. And then you adjusted your tops again. The first top was 1, the second top was 2. What's missing in this first denominator is that x. So you multiplied here by x. So that if you did the hand trick, now I got them in the wrong spots, but if you did the hand trick where you covered up the two things, you got your original fraction back. Over here on this next one, you're missing the x plus 1. Where again, if you do the hand trick and you cover up the same thing on top and bottom, you get your original fraction back. Okay? So then this became 2 plus, oops, excuse me, not 2. Reading and writing at the same time. This becomes x. 1 times x is x. 2x times, or 2 times the quantity x plus 1 is 2x plus 2. And all of that is still over x times the quantity x plus 1. And then, so in the end here, you get 3x plus 2 all over x times the quantity x plus 1. Agree with me on that? Trig, it's no different. Okay? In trig now, we're going to have something that looks like that. And we're going to say to ourselves, self, we need a common denominator. And in this case, the common denominator is going to be sine of theta times 1 plus cosine of theta. This one started out with a sine. This one started out with a cosine. What's missing in the first one? My left fraction, what's missing? Sine of theta. In my right fraction, what's missing? 1 plus cosine. Okay. Left fraction, the numerator is sine squared. Right fraction, the numerator is cosine plus cosine squared. Still over sine of theta 1 plus cosine of theta. Are we starting to see why it's so important to write out our work? Okay. Can I simplify my new fraction? What do you think, Zoe? Because sine squared plus cosine squared is 1? Hold on, let's do one step at a time. So those two together are 1. That's the hammer. That's number 7. So we get that. Can I simplify that fraction? We got. No, I would not distribute the sign at the bottom. Good try though. Nor? Both 1 plus cosines cancel each other out. Yep. Yep. I got a 1 plus cosine on the top. I got a 1 plus cosine on the bottom. Those cancel each other out. That leaves me with 1 over sine of theta. And what is 1 over sine of theta? Cosecant of theta. Questions, comments, concerns, clarifications? Yes, ma'am.
Can you always like multiply by doing like that? Like when you first start?
By all means, 100% you can. But you might find something that's smaller. You know what I mean? Like if we go back to the mathematical type 1. You know, like 3 and 5, yeah, got to multiply them together. Okay? But if it was like 2 and 4, you know what I mean? I wouldn't have to do the 4 because I could just multiply the 2 fraction by 2. With me? Okay? You know, I wouldn't have to I could go to 8, which is fine, but I can also just go to 4. Okay? With me? Try that one. So that gives me 1 minus sine of x plus 1 plus sine of x all over 1 plus sine of x, 1 minus sine of x. On top, that gives me 2. On the bottom, that gives me 1 minus sine squared of x. Agree with me on that? Now the bottom becomes cosine squared because I've shown that it's 1 minus sine squared of x. Yes. Yep. I'm just making sure everybody understands how we got to the 1 minus sine squared. So then this becomes 2 over cosine squared of x, which is 2 secant squared of x. Questions, comments, concerns, clarifications? Multiplied it out, yes. Yep. And by now, one of the things that you should have memorized in mathematics is if you've got conjugates and you're multiplying those conjugates, okay, that's what these are, conjugates, a minus b, a plus b, okay, those are conjugates, that is equal to a squared minus b squared. Okay? And that works in both directions. When we factor, if perfect squared minus perfect squared factors to conjugates. If it's multiplying the conjugates, multiplies into b. Perfect squared minus perfect squared. Okay? Love it. Try that one. I get cotangent of x. Questions, comments, concerns, clarifications? Good. All right, let's talk complementary angles. If two angles are complementary, then they add up to be 90 degrees. Okay? Okay? So 48 and 42 degrees, okay, are complementary angles. 30 and 60 are complementary angles. Okay? How can I algebraically represent the complement of an angle? Let's say our original angle was x degrees. What would the complement of that be then?
-x.
90 minus x degrees. Yep. Okay. In radians, what would that be? Let's call our original angle now in radians. Let's call it y radians. What would the complement be? What's the complement then? Say it louder still. Pi over 2 minus y radians. Okay. Now that opens up an entire column on your identities sheet. Oops, taps the brake, doesn't quite open it up yet. If I had a calculator, oops, I should switch these around. Let's do this on the fly. I don't think I can do this on the fly or not, because I don't think that they are. No, they're not. That's right. We'll leave it. We'll leave it as is. If you have a calculator, it doesn't have to be one of our big old grapher ones. You can just use a regular old one. If you and your shoulder partner, so whoever's right next to you, one of you do the sine, one of you do the cosine of those two angles right now. For the sine of 70 degrees, I got 0.9397. For the cosine of 20 degrees, I got 0.9397. For the sine of 68 degrees, I got 0.9272. For the cosine of 22 degrees, I got 0.972 also. What do you notice about the sine and the cosine of complementary angles? They're the same, right? Okay. So the sine is the cosine of its complement. Likewise, the cosine is the sine of its complement. That now opens up for you entirety of column number 2. So this is numbers 12 through 17 on your identities sheet. Okay? So what this is saying is the sine of an angle is equal to the cosine of its complementary angle, and vice versa. The cosine of an angle is equal to the sine of its complement. The tangent of an angle is equal to the cotangent of its complementary angle, and vice versa. The secant of an angle is equal to the cosecant of its complementary angle, and vice versa. Again, these are all 12 through 17, that's the middle column. So basically, if you see, this also works for, I will say that this would also be like if you had the tangent of 90 degrees minus x would equal the cotangent of x. Okay? Pi over 2 and 90 should be almost instantaneously interchangeable in your brain and in your reading at this point in time. Okay? So if you see something like that, instantly your mind should go to middle column on my identities sheet. Okay? Let's put that to work here now. Okay? Sine of negative x. Which identity is that? 2, and it's equal to negative sine of x. Secant of pi over 2 minus x. To me, that is number 17. And number 17 says that that is equal to the cosecant of x. Would you concur? Okay. Now it just becomes a problem like we've been doing for the last 48 hours. Okay. So I've got negative sine of x, and that's going to be multiplied by 1 over the sine of x. Those signs cancel each other out, leaving me with negative 1 times positive 1, which is negative 1. Oops, it's the wrong color. Leaves me with negative 1. You try that one. Sine of theta is sine of theta. Tangent is sine of theta over cosine of theta times cosine of theta. Those cosines cancel each other out, leaving me just with sine of theta. Cosine of pi over 2 minus theta would be sine of theta. So I've got sine of theta minus sine of theta, that's 0, plus sine of theta gives me just one single solitary sine of theta. Questions, comments, concerns, clarifications? In your homework packet, you should be able to do by now actually I don't want to say do now, can do. Yesterday we gave you numbers 1 through 16. You for sure can do all of those right now. And I'm going to add in today numbers 27 through 33. You can also do all of those at this time. Okay?